The purpose of this video is to introduce you to the elements of a System2 rear ventilated rain screen, a holistic system approach that was created specifically for lightweight facade materials. The S2 design guide is founded on the basic principles of the DIN standard 18516 ventilated facade. We'll reference design details from our S2 design guide, so we invite you to download a copy from our website at engineeredassemblies.com so you can follow along. In the next few minutes, we'll demonstrate the following 4 main design principles that our S2 design guide is founded on: coefficient of expansion, contraction, ventilation, vertical subframe design, and structural performance. Facade systems often experience expansion and contraction through the influence of thermal deltas as well as other factors, and need to respond to the dynamics of substructure as well as superstructure. By allowing some modulus of freedom, materials can respond to these fluctuations and dynamism, avoiding structural failure. This is accomplished by designing in fixed points and floating points. Facade materials now have room to move, so to speak, to adjust to the live nature of their environment. Here we see a floating point, and this is a fixed point. As panels expand and contract, they do so from the fixed point. In our System2 design guide, you'll find details for this expansion-contraction principle as shown here. This is a primary principle in the proper performance of an S2 RVRS system. Next, we'll show you how our second principle, ventilation, is another key component in our design guide. Ventilation is important to the S2 RVRS as well as any high-performance facade system. The uninterrupted airflow created by this design allows air to enter into the bottom of the building and exhaust all the way at the top, creating a nice active plenum or chimney effect. The active plenum provides enhanced performance by keeping facade assembly dry through proper ventilation. Additional thermal performance is gained by this highly functional plenum. A vacuum is created by the movement of air within this 25 mm unobstructed cavity. The nature of a high-performance permeable membrane is to allow vapor to exit. The vacuum pulls the vapor through the membrane. This helps to keep the insulation plane dry. The next principle involves the vertical subframe design. Panels are fastened to vertical hat bars. Module size of the panels determined in design, in turn, determine the location of the hat bars as support along the horizontal axis. This method provides unrestricted design freedom. Hat bars must stop and start at traditional points of deflection in order to avoid lockup. A single panel cannot share or be fastened to 2 separate vertical hat bars in succession on either side of a traditional point of deflection. Expansion and contraction of the panels, along with that of the substructure and traditional dynamics of the superstructure, must be respected for the longevity of the facade. The fourth principle of our design guide is structural performance. Proper design and spacing of substructure members will create a deflection limit of L/300. This will ensure the substructure can support the panels as required. Installation using the principles of the System2 design guide will maximize the life of facade. All these elements combined create a holistic system approach following these 4 main principles. Thank you for joining us. We trust you have a deeper understanding of the System2 rear ventilated rain screen system and the important role of each of the 4 main principles. Have questions? We'd love to hear from you. Visit our website to find a representative near you. Thank you.